In this lesson, we'll take a quick look at how to connect and utilize the Fast Subsurface Scattering Light Map node. So this light map node is an essential part of getting the fast subsurface scattering shaders to work properly. Now in Maya 2008 and higher, the light map nodes are created for you automatically anytime you generate any of these subsurface scattering nodes. So for example, I'm using Maya 2009 right now, so if I were to add the fast subsurface scattering shader, you'll see that it creates the shader for us and it automatically creates a few extra nodes that are connected in. So let's take a look at what we have. So let's just make this a little bit easier to see. And let's select this node. Take a look at the input and output connections, so that way we can get access to the shading group. And now, with this shading group selected, let's take a look at just the input connections. Alright, so really what we want to see are these four nodes right here. So these are all critical in order to get subsurface scattering to work correctly. Now as I mentioned, in Maya 2008 and higher, these nodes are created automatically. However, anything older than Maya 2008, you would have to come in and manually create these nodes in order to get the subsurface scattering effect to work correctly. So, just for demonstration's sake, I'm going to take these two nodes and disconnect those, so that way we can see how to manually add and connect them. So let's start with the Fast Light Map node. So if we scroll down, this can be found inside the Light Maps tab, and we're going to use the Fast lmap Maya. Alright, so that will create this node for us. Now this needs to be plugged into the light map port of our shading group. So we'll scroll down, take this, middle click, drop it into the light map shader. Now let's take a look inside here. So if we go to the light map node and go to the light map right, this is critical because the information from this node will be written out into a map. That map will then be read back into the shader and be displayed as the subsurface result. So what we need to do is make sure that we define some kind of a light map file for it to write information out to. So that will go ahead and create a mental ray texture for us. Now before we connect this in, there is actually a few changes that we will want to make on this particular node in advance before we actually connect this up and make the subsurface scattering effect work properly. So in the mental ray texture node, let's come in and make sure that this is set to be a writable file, so that way you can actually use the information that will be written into it from this light map node. So make this set to writable, and now we can define some sort of an image height and width. So what we want to do is for the file size height, we want to make this the same size as our render settings. So if we take a look inside the render setup, and if we were to take just a quick render of this, let me go ahead and take this render view, make this a little bit smaller. And if we want, we can just take a quick snapshot here, and we can see the actual image resolution. So we're using right now 640 by 480. So for the image height, we want to make sure that this is set to 480, so that way the subsurface effect will actually match the resolution of our image. Now for the file size width, we want to make sure that this is set to be double the size of our current image resolution. So right now we're rendering out as 640 by 480. So 640, double that, that will give you 1280. Alright, now why do we want to make this width double our resolution? Well, the reason is because this subsurface scattering shader will write out information for the front scattering effect and the back scattering effect. And so as a result, it needs actually image size and room in the image in order to write both sets of information out. So we want to make sure that we provide enough room for it to write the full resolution of the back scattering effect and the full resolution of the front scattering effect. So that's why we need to do this. Again, if you're using Maya 2008 or higher, this will all be automatically set up for you. Now let's also make sure that the file size depth is set to 32-bit, so that way it can write out the full color spectrum. Now when it comes to providing an image name, this is something that we can either do optionally or not. If we leave the file name blank, it will just write the subsurface effect out into RAM and then just bring it back in. If we were to define an image name, that will actually write this into a file. So we'll see the result here in just a moment. So now, as a last step, all we have to do is go back to our subsurface shader, take our mental ray texture, middle click, and make sure it's connected into the light map. Alright, so here's pretty much what we have. We have the subsurface scattering node that is able to write its surface information out into the actual shading group. From there we have the actual light map node. Now this is actually going to generate the light map, which will be written into this file. That file information and coloration will be read back in by this node. So we really kind of have this circle of effect that we have here as far as being able to write this information out and then read it back in, if you were to kind of follow this around in a clockwise pattern. So let's take a quick look at what we have right now with the subsurface scattering effect. And now you should be able to see our subsurface scattering working properly. So as one final step for this, if we wanted to actually write this information out into a self-contained image, we could just go back to this mental ray texture. We could set the option for local, so that way it'll write out some sort of a local file. Then all we have to do is define an image name. So we can't actually define just a random image name that doesn't exist. Mental Ray prefers to have some kind of an image already in existence that it can write information to. So we need to come in and make basically just a little dummy file for this. So let's just right click, we'll go to new, and we can create any kind of a file that we want. We can just create a simple text document for this. Now nothing has actually showed up here in our viewer. So let's make sure we switch the filtering to best guess, and there we can actually see it. So we can call this anything that we want, SSS, and we can give this either a .iff or a .map extension, but we do want to make sure that we give it some sort of extension. There we go. Yes, we do want to change the extension, and there we go. Now we've created this empty dummy file that we can now point in as the image to be written to. So now the next time we render, we should be able to then come into our images directory or whatever directory we've defined and then take a look at the image that we've decided to write out. So here's our SSS map, and you can see now it has a image file size of around 5.5 megabytes. So there is definitely information in here. And if we double click on this, we can use our F-check to actually see the information here. Now right now you really can't see the information all that well because it is writing this out in a 32-bit format. So unfortunately, due to the limitation of F-check, we actually can't see all the information that's contained in this file. But you can definitely see that there is a small slice of information that we can see right down in this corner. So this does give us the ability to write information out into a self-contained map and then utilize this somewhere else if the situation arises. So that's a look at how we can utilize the fast light map node and how we can make the manual connections in order to get subsurface scattering to work properly.